Hello, it's Keith here, and this is lesson 6 of the ChibiAkumas series of my Z80 programming tutorials. Now, we've looked over the last couple of weeks at how the star array works, that's the bullets, and we've also looked at the object array, which creates the enemies, and at points in there we've had to look at the player's current location, and this comes into the settings data that defines the game's system settings, the high scores, the control mechanism, and also the current attributes of the player, like the current location, the power-ups the player has, and the remaining lives. So we're going to look in some detail today at the settings data, because as we look in more detail at how the player is controlled and the sprite is drawn and things, we're going to have to look at this in greater detail. So I think it's time now to really make sure we understand it, and that way we'll be able to understand how things work going forwards. So what is the settings data? Well, the settings data is essentially a bank of memory within the so-called core of the game, which is constantly in memory, and it contains all of the settings of the gameplay. For example, how many lives you have when you start. It has things like the current lives of the player, the smart bombs the player has left, the position of the player, how fast the player can shoot, and so on. It also has the controls that are defined in the main menu. So there are two sets of controls, one for player 1 and player 2, and also the high score and the current score. Now, things like the player settings and the high score, there were two copies of this, one for player 1 and one for player 2. And we're going to have a look at that later. So, as I say, the settings data is held within the core, and whenever the game settings are updated, either because you've ended a game and your score's changed, or because you've changed the settings or changed the key configuration, it is resaved back to the disk, assuming it's a disk system. Now, this is saved into a file with a name similar to settings.vo2. vo1 was done by ChibiAkumas 1, you see. The file name is slightly different on the Spectrum because of shorter file length limitations, but it's basically the same. And what happens is this is loaded in from the disk when the game starts over the default settings that are held within the core itself. Now, if you do something crazy like set all of your controls to invalid things, or you manage to corrupt the file somehow, then you can restore everything back to default by deleting settings.02 from the disk, and everything will reset. And that's why that's a recommendation if you're having trouble. And there was a bug at one point where the V9K version was loading the non-V9K settings and then was getting confused and the entire game was crashing. So that's a good thing to try if there's real problems, but to be honest, you should never need to do that. We're going to have a look in more detail at that in a moment though. But first, let's discuss the ways that we access these settings data. Well, as I say, the settings are held in the core, but it's not like the jump block that there's a guaranteed position they're going to be in. So what we have to do is, within the core and the bootstrap, they're both compiled at the same time at all times. So they can access any setting by direct quick labels. However, in the level code, which does not know what the current state of the core's compilation is, we have to use the jump block to access certain points. And we have to use offsets to get to the other variables within the settings block, because while the settings block is standardized, the position of the settings block in the core is not. So, what do I mean by that? Well, let's look at it in detail. Well, the first thing that is often very important is the player settings. Now, each player has 16 bytes of settings, so when we want to set the Y position and the X position of player 1, we call this jump block command called getPlayerVars here. This will set IY to the player 1 variables. Now, the Y pos is always the first at position 0, so if we want to set the Y position within the level code here, we just do getPlayerVars and then set the new Y pos to IY plus 0, and the X pos is just IY plus 1. Now, getPlayerVars gets the first player. There's no second jump block command for the second player because there simply wasn't memory for it. But what there is there's a standardized symbol called player separator here, which is the size of the settings data for each player, and you're guaranteed that the second player will follow the first. Now, the settings are always 16 bytes in size, but if I had needed to add more later, I would have changed this player separator parameter. So anyway, all we need to do to get to player 2, we just need to add player separator to IY plus 0 here, and rather than getting the Y pos of player 1, we will now get the Y pos of player 2. And of course, we could actually do a mathematical add command by setting HL to player separator and doing an add there if that was what we wanted to do, but there was no need in this case. So that's how we can change the player settings. Well, what else can we do? Well, as well as the player settings, there are other variables that are useful to us. Now, positive values like 0 and 1 and 2 and so on are the player settings, but minus values are the system settings. And the main one we will use in the level code is number -1, which is the current system, which rather confusingly is called CPC version, a hangover from the Amstrad CPC, the original system ChibiAkumas was written for. Now, this parameter will change depending on the hardware, but it is essentially the hardware that's being detected. And we can use this on the MSX to detect if we've got a V9K. So bit 0 will be a 1 if we've got a V9K, and it will be a 0 if we have not. And so this will be seen within the level block to change the background to use the more advanced V9K background or the regular one. Now, I obviously know it's very confusing to see just -1s and +0s here, but we're going to go through these in detail in just a moment. So, as well as the ability to get system settings using negative values and player settings using positive values, we can also get the high score. This is actually only used on the main menu, but there is a jump block for it. So we can just use get high score here, and that will return the address of the high score. If we want player 1 score, we can actually subtract 16 from that to get it, or we can subtract 2 to get player 2 score, and that's the layout of the data that's causing that to work like that. We're going to go over all of the source in a moment, so you'll actually see it as it appears in the core source code. Here's a very quick summary of all the variables. You can see these are the labels that are accessible within the levels code, and there's very few because they have to go through the jump block. These are the quick labels which are accessible from the core or the bootstrap, and you can see there's an awful lot of them because it's actually more efficient to use a label within the core to get to the player settings if you don't need to support either player. Now here's the purpose of each, and you can see that different byte and bit commands will give different attributes. We're going to go over all of these in just a moment. I'm just showing you the table so you know that it's there. So now that we've had a very quick overview of how we can use the core settings, let's have a look at them as they actually appear within the core. So here is the core file here, and it firstly reads in the bootstrap, but we're not going to look at that today. Now here's the Aku logo there. And we've got some settings that we're not going to look into today. Here's the jump block. This is where all of our common positions for commands appear within the core, and we can call all of these from the levels, knowing that set current is going to be in the same position every time, because any new jump block commands will be added to the end. But that is why we can't rely on the position of saved settings, because it could change. So here's saved settings, and you can see this is -20, which is relative to the player array. Player array is what is returned by that jump block command get player vars. So we'll go upwards so that we can see what -1 is, and -1 is the CPC version, or the system version would be the more accurate description. So here you can see we've got various options that can be returned. On the CPC we'll detect 0 for 464, 128, that's bit 7 of course, for a 128K system. 129 will be a 128K plus system, so CPC plus 128. Now I've just noticed a typo here. 192 is a 128K system with 512. Essentially bit 7 is the 128K system bit 6 is the 512K bit system bit, and bit 1 is the CPC plus bit. So that's a typo there. 192 is a 128K system with 512K. 193 is a 128 plus CPC plus with 512K. And this is at position -1. So we load in the player array, read in IY -1, and we will get the system version. That's the CPC. There are some options on the MSX. The bit 0 will be detecting a V9K, and bit 2, which is a value of 4, it will detect a turbo R. It actually also detects a WSX, but that's never used. Now the ZX spectrums, there's the bit that represents what the disk system is, which is actually honestly never used, but it's there. And then we've got a detection for 128K systems, although ChibiAkumas requires 128K. And then we've got a bit for detecting the +3 and the black +2, which are the Amstrad versions with the extra memory. Now I'll be honest with you, none of these bits are ever used. I put the functionality in, but there was no place for it to work because I don't do any clever detection of the +3 and the black +2, and also the disk systems are actually hard-coded into the core. These are actually used because in some cases the code will change the way it functions on a Turbo R and on a V9K, but the Spectrum ones are never used. So what about the next two? Well, these are the visible and active screen, the first byte of the memory address of the screen. Now you can see here they're both C0, but in practical purposes, the visible screen would be C000, and the active screen that's being written to would be 8000, and then they would flip over. So this is where you can read in the current memory position of the screen if you want to make the level write byte data straight to the screen. Block paged flip colors. This is another slightly misleading one. The functionality of it isn't accurately represented by the label, unfortunately. What this does is on the CPC Plus, the sprite of the player can flicker on and off very quickly so that you can see the bullets through the sprite because there's no layering options for the CPC Plus sprite. So if you set this to 255 or 0, that will turn it on. If you set it to 64, it will turn it off. The reason for this is as I do a CPL command to toggle between the two options. So anything that's not 255 or 0 will turn this off. And the same for heavy page flip colours, which is where on the Amstrad CPC, some of the levels on the non-plus version, I was toggling between two palette options to kind of effect an in-between colour on using the persistence of vision on the CRT displays. It doesn't work so great on emulators, but ironically it does work okay on my arcade VGA emulation box, even though I'm using a TFT. Quite strange there, but that's what that is. As I say, this one is incorrectly titled, but this one is fairly accurately describing what it's doing. Timer ticks is not used anymore. It was something I used for testing purposes. I was making the core update this so that I could see how fast the game was running during interrupts, but that's turned off now because it's a waste of processing power. Live players returns how many players are living in the game. So if the game is started with one player and then a second player starts, live players will move up to 2. If one player dies, it will go down to 1. If the other player dies as well, it will go down to 0. So this is a way of detecting how many players are currently in the game. Turbo mode, this was another experimental function to try and make the game faster. It allowed you to turn off the backgrounds and the music and the raster colours. I disabled it because basically there are two reasons really. Firstly, it would have made the debugging a lot harder, having to test all these possible permutations and combinations. The other thing is if you turn off the music and the raster colours, the game looks awful, and I didn't really want to encourage people to play the game looking so bad. So it doesn't work anymore, I don't think. Multiplayer config, another unfortunately misleading title function. The multiplayer on the Amstrad CPC is a special upgrade. This allows two joysticks or joypads to be connected to the Amstrad CPC, but there's no key ghosting where you have multiple keys pressed down and other ones lock up. So this is a more advanced function, but you have to enable it, and so the lowest bit is to detect if it's installed, and then the next bit is an option to flip fire buttons 1 and 2, because the multiplayer is a hardware joypad and it's not processed through the same key controls, so you can't redefine the keys for the multiplayer. To be honest though, to my knowledge, no one has ever played the game with the multiplayer except me once during testing, so a bit of a waste of a function there. I said it's a bit misleading though because it also has a function on the ZX Spectrum. This is used to detect if the Kempson is active. You can enable the Kempson in the settings, and this is then set to 1 to turn the Kempson functionality on. Because if I tried to use the Kempson on a machine without one, I was getting malfunctions where it thought the fire button was constantly being pressed. So that's why I've disabled it by default there. Achievements are an episode 2 function. If you did special things within the game, like shooting the bunny ears off the first boss, you would gain an achievement unlocked. And you would get a special bonus that you could see the eye catch screens. And these are like little wallpapers of the characters with a bit of bio and things. So if you unlock all of these, then you would get extra things. And also if you've won the game, then you would be able to change to 4-direction mode, which is where you can shoot up, down, left and right at all times in all levels. So it was a bit of a bonus there, and this is used to store those. In episode 1, the only one that's used is the 1 function, which allows you to play in that 4-direction mode. Game difficulty, well, this is very complicated but is not fully exposed to the player. There's 3 different options for fire speed. There's a heaven mode which has different fire patterns, and also there's a star speed option as well. This was sort of summarised down to 4 simple options within the game menus, because having so many permutations and combinations would have confused the user. And again, I've never heard any feedback on whether people like it or not. I don't think anyone uses it. Continues reset. This is how many continues you have when you start the game. So you can see it's set to 60 by default. Smart bomb reset. Again, this is when you die. How many smart bombs do you start your life with? And the only thing with this is it has to be 3 maximum, because using the hardware sprites on the CPC Plus, I couldn't have easily drawn a 4th one. So that's a hardware limitation to the fact you've got 3 lives and 3 smart bombs. Continue sharing. This is a function for the 2-player mode. I wanted to create a alternate dynamic where the players would be kind of competing against each other, and the way I came up with this was there's 2 options. You either have one set of continues for both players, so if you've got 60 continues and player 1 dies, you're down to 59, and then if player 2 dies, you're down to 58. Or each player can have their own continue stock. So if both players have 10 continues and player 1 dies 9 times, they will only have 1 continue left, but the other player will still have the 10 continues. And so this encourages the players to steal the power-ups from their co-player and basically try and avoid the danger and do as little as possible to help out the other player. because now you have no vested interest in the other player actually doing well in the game, because if they die quickly, you get to do everything. And in fact, the game does actually make the difficulty harder if there's 2 players in the game. If one of the players dies, the game gets easier again. So here's the play mode. This comes back to that multi-direction that if you've won the game, you can turn on. So normal is the default, and then 4-direction mode is where you can shoot up, down, left and right. Game options is very simple. There's a screen shake option in episode 2 where the screen will shake violently at some points because it's quite uncomfortable and it can actually play up things like my VGA box don't like it. You might want to turn that off, and that's what that's for there. And we got some spare bytes here, so we can add a whole extra 4 options here. Now, one thing I will point out at this point, some of these bytes are very sparsely used. You'll notice there's a whole 7 bits not being used in this byte. I could have actually merged other things into there, and originally with the player data, that's exactly what I did. I was really being tight with every single bit of the player settings. The problem with doing that is you actually end up with a lot more code to use those settings and a lot of processing power wasted. So I actually removed all of that code and simplified the player array so that I'm using more bytes of player data and less bytes of program code. And I think, in all honesty, that's the best way to do it. It's not saving 1 or 2 bytes of settings data doesn't make sense because you will use more than 1 or 2 bytes reading and writing that data back. So here's the player arrays then, and these of course are in the positive direction. So this, as you can see, is position 0 and this is position 1. And I should have pointed out, you can see all of the negative positions here if you need to look them up. They're not very well aligned here. They may be better in WinApe, I'm not sure. But as I showed you before, if you're unsure, just look at this list here where they are neatly aligned, hopefully, and make a bit more sense. And so here's the player array, and you can see that Y is 0 and X is 1 here. And you can also see there's these alternate definitions. P1 is player 1 and 0, 0 is position 0. And if you look up here, when we were discussing this before, we were loading in the player's position to configure the object array within the core. And you can see here we're using these direct labels because this is actually more efficient in terms of memory and processing power than using IY and pointing IY to player array and then doing +0 and +1. That takes far more bytes, you see. So that's why we're doing that. Shoot delay. Well, if the player holds down fire, the bullets will fire at a certain controlled speed, and there's actually a power-up that increases that controlled speed. So this will turn to 0 when the player can shoot, and then it will be set to non-zero for a while until the timer ticks of the game engine reach that point, and then it will be set to 0 again. So this is a way of controlling the player's shooting speed. Smart bombs is pretty self-explanatory. How many smart bombs the player's got left? Drones are also self-explanatory. The drones are the little pentagram kind of stars that appear above and below the player and can shoot. So if the player's got none of those, then these will be set to 0. One interesting thing to note, players 1 and 2 together can only have a maximum of 2 drones. That's a hardware limitation again because the CPC Plus was using 4 sprites for the player. That's 2 players, 8 sprites. It was using 6 sprites for the lives and the power-ups, and that only left 2 sprites remaining. And that meant that we could only have 2 drones in total. If you're sharp, then you'll actually notice there's 3 hearts at the top and there's the 3 smart bomb icons at the bottom. But they appear on the left and right for both players, and that is actually more than the 16 sprites the CPC can handle. And there's a trick in there that I'm actually relocating the sprites while the screen redraws. So I'm drawing the top 2 and then swapping them over for the bottom 2, and I'm tricking the hardware of the CPC Plus to draw more sprites on the screen than it should be able to. So that's a little trick in there that you might be interested in, and we'll go over how that works in more detail later. So here's the current continues the player has. Here's the offset from the player's position to the drone position. Now this is subtracted for the top drone and added for the bottom drone. Invincibility is the time that the player is going to be invincible, and they're invincible of course whenever they're hit. Sprite number is literally the sprite that the player is showing at the time. Now, the sprites toggle between 2 options, but there's a left option and a right option and an up and a down option if you've got that extra mode after the game's been won once enabled. So this remembers the player's sprite number for the direction they're facing. Lives is obviously how many lives they've got left. Burst fire is a special function that was added with episode 2. For every 100 coins you will get 10 burst fire options, sometimes called crossfire. The reason for this is when you hold down both fire buttons, your player will shoot in all 4 or all 8 directions. Now if burst fire is less than 50, you will only shoot in 4 directions. But if you've got more than 50 burst fire, you'll shoot in all 8 directions. And this gives you a way of hitting things that are above and below you if you're not playing in that special mode. player number, this is a constant. It's 0 for player 1, and it's 128. That's actually wrong for player 2. Sorry about the bug there. That's actually 128. Now, why is it work? What's this for? Well, there are some functions within the code that are generic for both players, and I pass the players array in IY to those functions, but the functions need a way of being able to detect which player they're actually working on for things like seeking objects, and more importantly for when the player is shooting. And that's why this is 128, because 128 is added to the move parameter of stars when the player shoots them. So that's why that's 128. Here is the points that are being currently awarded to the player. So whenever you collect a coin, the 5 is added to this, and that will be decreased one at a time so that there is a rolling up effect of the scores. So this is kind of a temporary buffer for the score that's not been yet stored in the final destination for those scores. Player shoot power, this is the double shot power effect. If this is set to 1, then the player's shots will do twice the damage. I think I've actually missed fire speed. Now this is relating to the shoot delay. This is altered, and this one is moved 1 to the right when the player gets the speed power up, and this is used to reset shoot delay whenever the player fires. And then finally we've got fire direction. Again, this is relating to mostly the 4 direction mode where you can shoot up, down, left and right. So this remembers the direction the player last fired, because in 4 direction mode you've got one fire button that you press to fire in the direction you're currently moving, and the other fire button to fire in the same direction as last time, if that makes sense. So this is to remember that direction that you last fired in while moving. So this is exactly the same now for player 2. So there's no changes at all. All of this is exactly the same as player 1, with the exception of this 128 here. Now we're on to the key maps, and you can see that the key maps, there are different versions for each system because each system has different ideal key controls, but the theory is basically the same. Here you have a mask. This is the bit that we're looking for to be pressed down. So in this case we're looking for bit 7 to be pressed down, and this is the row number of the keyboard system. So if bit 7 is down, i.e. 0, in row 5, then fire 3 is being pressed. And you can see there's a set for player 2 here, and there's a set for player 1. And yes, we do have 2 pauses for both players. No real reason for it, but that's what we have. Key presses, keyboard scanner key presses, is a buffer for the direct key presses from the system. This is used for the redefined keys to work out what key was really pressed, and also for obscure things like configuring the cheat mode where you have to press special keys on the keyboard that aren't part of the defined key map here. You will notice that the size is slightly different on different systems, but it doesn't really matter. Now moving on, we've got the scores here. You see these have to be byte aligned because the code relies on it. The high score is the only one you can request through the core. You saw that Aku6 get high score, and you can see the bytes here. These are actually in reverse format. So this is the least significant, and these are actually non-packed binary coded decimal. So each of these can only go from 0 to 9. And so we have 8 possible digits here. So if there was a 1 here, then our score would be 1. If there was a 1 here and a 2 here, then our score would be 21. It's kind of backwards for reading for the user, but it makes a lot of sense for the machine. And so this is player 1's score, this is player 2's score, and this is the high score. And you can see here there's a marker for the end of the settings buffer, because every time the settings are changed in some way, this entire bank of memory from here to the bottom there are saved, and when the game is loaded, they are reloaded. So there we go. So that's a bit of a quick introduction to all of the settings. Now, I don't know if that was really interesting to you. I don't know if it made any sense. We are going to go over all of these kind of things later when we start looking at the code itself, especially the player settings code. So it's going to come up again, but I needed to be able to say that I had shown it to you and explain it to you so that there was something for you to kind of latch onto when you see it later. But if you didn't understand it, please feel free to comment, of course, and I'll do my best to explain it better, and if necessary I'll put extra comments in the website. So please always go to the website and just check if any mistakes have been corrected or any extra comments have been added. And I will be adding sort of comments and things to the source code here, because eventually it's all going to be put into the Chibico versus the Coding Bugs game that's going to be released alongside these tutorials. Anyway, that's it for this week's lesson. I hope you've enjoyed it. Thanks for watching and goodbye.